Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to work out the questions from the full-length practice test on my website. In case you want to go to my website and take that, here's the link right here. Otherwise, if you want to use this video to take this practice test, here's what I recommend. Specifically, I recommend that after I read each question, you pause the video, attempt to work out the question on your own scratch paper, and then resume playing the video to check your solution. Just as a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB. So if you're taking this practice test, try not to use any of those resources. In addition, I want to mention that I'm going to include timestamps in the description of this video. Next to the timestamp is going to be the topic that the question's testing, as well as a link to a video where I discuss that topic in greater detail. So if at any point during this video you feel as if you need additional help, just check out the description and there you'll find additional resources. So all those things being said, let's go ahead and get started with today's video. All right, so this first question says, simplify the expression. We have 1 to the 4th times 2 squared plus 3 to the 3rd inside parentheses minus 2 to the 5th divided by 4. So whenever you have to simplify expressions that are all mixed up like this, you're going to make use of the order of operations. And in case you forgot what those are, you can remember them by remembering PEMDAS, that is, please excuse my dear Aunt Sally. This tells you the exact order in which to simplify this expression. You're going to work on parentheses first, exponents next, multiplication and division as they appear in the expression from left to right. That is to say, multiplication and division have equal precedence. And then finally, you're going to work on addition and subtraction as they appear from left to right. Again, those have equal precedence. So for example, if subtraction in the expression came before addition, you would do subtraction. Okay, so with that said, let's go ahead and copy this one down and make sure to take your time as you copy the questions down on your scratch paper. It's very easy to make a simple mistake that way. In fact, I did that in my video yesterday. So again, you don't want to get a question wrong because you copied it down wrong. So with that out of the way, we're going to scan through this expression and see what we have. Obviously, we have a set of parentheses. So that's the very first thing we're going to take care of. And inside the parentheses, you can think about the order of operations starting over again. So inside this set of parentheses, is there another set of parentheses? There's not. So we're going to move on to exponents. And as we can see, we have 3 exponents and then we have multiplication and addition. So we're going to do the exponents before the multiplication and the multiplication before the addition. So let's go ahead and take care of those exponents. 1 to the 4th is always going to be 1. 1 raised to any power is always 1. 2 squared, that's the same as 2 times 2, which is 4, plus 3 to the 3rd. 3 to the 3rd looks like this. 3 times 3 times 3. Well, 3 times 3 is 9. 9 times 3 is 27. So this is plus 27 minus 2 to the 5th divided by 4. All right, so we took care of our exponents inside this set of parentheses. Now, as we can see, we have a multiplication and addition left. According to the order of operations, multiplication comes before addition. So we're going to take care of that right now. 1 times 4 is 4, okay? Minus 2 to the 5th divided by 4. And finally, we just have addition inside this set of parentheses, so let's go ahead and take care of that. 27, 28, 29, 30, 31. So this is 31 minus 2 to the 5th divided by 4. So we just took care of the order of operations for what was inside the parentheses. Now we have subtraction, an exponent, and division left. Okay, so exponents come before division and subtraction. So let's take care of that exponent. So this becomes 31. And I'm going to work this out. This is 2 to the 5th, which is the same as 2 times 2 times 2 times 2 times 2. That's 2 by itself 5 times. This is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So this is 31 minus 32 divided by 4. And as you can see, we now have 2 operations left to perform. We have subtraction and division. Well, of course, division comes before subtraction in the order of operations. So we're going to take care of this division, and then we'll work on the subtraction last. So this is 31 minus 32 divided by 4 is 8. And now we just have one operation left, notably 31 minus 8. 31 minus 8 is going to be 23. So the answer to this one is 23, which is answer choice D. Okay? So that's that one. You will absolutely see a question involving the order of operations, so make sure you understand how to apply it. Again, your chances are you're not going to see this question, but you will see a question that's very similar. So just keep that in mind. All right, number 2 says, find the value of 3y squared minus 2x plus 4z if x equals 3, y equals negative 4, and z equals 2. So not surprisingly, I'm going to start by copying this one down. We have 3y squared minus 2x plus 4z. So as far as this problem goes, this is just a test of your ability to substitute these values into the expression accordingly. So in place of x, we'll put 3. In place of y, we're going to put negative 4. And in place of z, we're going to put 2. So let's go ahead and do that. We have 3. We know y is negative 4, so this is negative 4 squared minus 2. X is 3 plus 4, and z is 2. Okay? And if it's helpful, I mean, you could work this out using the order of operations. But at this point, that's not the focus of this problem. So let's keep working this out as is. I'm going to deal with this squared next, and let's go ahead and take care of that. This is the same thing as negative 4 times negative 4. A negative times a negative is a positive, so negative 4 times negative 4 is going to be positive 16. Okay, and this is minus. And let's just go ahead and work these two out. They're pretty easy to do. 2 times 3 is 6, plus 4 times 2, that's 8. All right, so 3 times 16. If you can't do that in your head, you're going to have to work it off to the side like this. It's no problem in doing that. 6 times 3 is 18, so you're going to have to drop down an 8 and carry a 1. 1 times 3 is 3, plus 1 is 4. So this is 48 minus 6 plus 8. And let's just pull up the order of operations to see what's going on here. Again, the order of operations is PEMDAS. And we have addition and subtraction left, right? Remember what I said, addition and subtraction are equals. That is to say, you do them as they appear from left to right. So we would work out the subtraction and then the addition, if you want to go back and think about the order of operations here. So 48 minus 6 is 42. 42 plus 8 is 50. So this one is B50. Nothing too challenging there. All right, number 3 says, what is 11% of 3,000? So I have a video on percents, and in that video, I show you how to translate these simple problems that trip up a lot of people into expressions that you can then solve. So let me show you how to translate this very quickly. What is 11%? Well, when you're working with percents, you're always going to work with them in decimal form. The decimal equivalent of 11% is 0.11. Of in a word problem always means multiply, and 3,000 is just 3,000. Okay, so this problem literally tells you take 0.11 and multiply it by 3,000. Okay, so that's what we're going to do. We're going to do 3,000 times 0.11. And as you can see, we're multiplying a whole number, notably 3,000, by a decimal, notably 0.11. In order to proceed, I find it easier to get rid of these decimals temporarily. So what I'm going to do is I'm going to shift the decimal place in 0.11 2 times to the right. This will become 3,000 times 11 or 11, albeit with 2 decimal places to shift back into the left when I'm done. So I moved them to the right here to get rid of them, as you can see right here. Once I work this out without the decimals, I'll shift them back into the left. So technically they didn't go anywhere. I'm just shifting them around so that the math becomes a little bit easier. So let's work this out. 1 times 0 is 0. 1 times 0 is 0. 1 times 0 is 0. 1 times 3 is 3. Before we start multiplication with this second term down here, we have to add a 0 placeholder. 1 times 0 is 0. 1 times 0 is 0. 1 times 0 is 0. And 1 times 3 is 3. Okay, now we're going to add these two together. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 3 plus 0 is 3. And 3 plus nothing is 3. Bring those two decimals back in. 1, 2. So the decimal's right there. We can see that 11% of $3,000 is $330. Okay, so that's that one. And this answer choice would be C. All right, number 4 says, if 4/3 divided by 1/6 equals C, then the value of C is between which of the following number pairs? So let me just rewrite this so it's a little bit clearer. We have 4/3 divided by 1/6, and that's going to equal C. So for this one, as you can see, we just have to divide these two fractions. And personally, I find dividing fractions very, very easy because you just follow the algorithm, keep, change, flip. So let's go ahead and see what that looks like in case you haven't seen it in a while. This keep, or K, refers to this first fraction. You keep it exactly the same. So we'll just copy that one as is. This change, or C, refers to the sign right here. Here we're doing a division. We're going to change that to be multiplication. Okay? So we did our keep, we did our change. Now we're going to work on our flip, and this flip refers to the second fraction. Here we have 1/6, so we're actually going to make that 6/1. That's the flip. And once you do that, now you just proceed as if you were multiplying fractions. When you multiply fractions, you just multiply straight across. So you multiply your numerators together, and you multiply your denominators together. This becomes 4 times 6 over 3 times 1. Of course, we know that equals C. 4 times 6 is going to be 24 over 3 times 1, which is 3. 24 divided by 3 is 8. So we can see that C equals 8. The question is, what is C between? Well, 8 is between 7 and 9. So this one is D. All right, so number 5 says, order the following values from least to greatest. We have 0.075, 0.75%, 3/4, and 1.2. So it should be obvious that all of these values are less than 1, excluding 1.2. So right off the bat, I'm going to say 1.2 is going to be my greatest value. Likewise, it should be obvious that 3/4 is the same as 0.75, and 0.75 is going to be bigger than 0.075 as well as 0.75%. So the very next one I'm going to list is going to be 3/4. Now it comes down to these two, 0.075 versus 0.75%. Well, let's deal with this point. 0.75%, since that's a little bit of an unusual number. In order to write a percent and decimal form, you simply place it over 100. You drop that decimal sign or that percent sign, and then we can convert this very quickly to a decimal. And how do we do that? Well, anything divided by a power of 10, such as 10, 100, 1,000, and 10,000, just prompts you to take that decimal and shift it to the left according to how many zeros there are in that power of 10. In 100, there are 2 zeros, so I'm going to shift this decimal place 2 times to the left and add in 0 placeholders accordingly. So 0.75% is the same as 0.0075. Well, 0.0075 is much smaller than 0.075. So this, if we order it, is going to be 0.75%, 0.075, 3/4, and 1.2. So that's going to be answer choice A. Okay, so that's that one. All right, number 6 says solve the following system of equations. We have 2x minus 3y equals -4 and y equals -2x plus 4. I'm going to start by copying this one down. We have 2x minus 3y equals -4. And then we have y equals -2x plus 4. So this is our system of equations. Right off the bat, we can see that we have a little bit of a problem. Whereas this one has x and y on the same side as the equal sign, this one only has y over here. So the first move I'm going to make is to rewrite this bottom equation such that it mirrors this top equation. Specifically, I'm rewriting it so that we have x and y on this side, which will match this top equation. So let's go ahead and do that. Again, to do that, I'm just going to add 2x to both sides. This will cross out here, and let me just copy these both over here. We have 2x minus 3y equals -4. Then we have 2x plus y equals +4. All right, now that I've rewritten the bottom equation to match the top equation, I'm going to make use of the elimination method, and specifically, I'm going to use the elimination method to get rid of this x variable, which is pretty easy to do. If I take this bottom equation and multiply it by -1, well, that's going to prompt me to distribute this -1 to all the values inside the parentheses, and then I'm going to add the two equations together. So when I do -1 times 2x, that's -2x. When I add that to 2x, that x variable is going to disappear. So let's see what that looks like. Again, I'm just going to copy down this top equation. We have 2x minus 3y equals -4. Let's take this -1 and distribute it here, here, and here. Again, -1 times 2x is -2x. -1 times positive y is -y. -1 times positive 4 is going to be -4. Now that we've distributed that, we can add these two equations. -2x minus 2x, this is eliminated, hence the name elimination method. Now we have -3y minus 3y, that's -4y equals -4 plus -4, that's -8. Okay? So now we're just solving for y, that is, we want to get y by itself. So we're going to divide both sides by -4. This crosses out, leaving you with y equals -8 divided by -4. A negative divided by a negative is a positive, so -8 divided by -4 is going to be +2. We've solved for y. In order to solve for x, you take this y variable, or this value for y, and you plug it back into one of the original equations. And those are right here. We have 2x minus 3y equals -4, and y equals -2x plus 4. I'm just going to plug it into the top equation. So again, this top equation is 2x minus 3y equals -4. We found y to be +2, so let's plug in 2 in place of y here. This becomes 2x minus 3 times 2 equals negative 4. This is 2x. Negative 3 times 2 is negative 6 equals negative 4. Let's add 6 to both sides. This crosses out here. It says 2x equals negative 4 plus 6 is positive 2. Finally, divide both sides by 2 to get x by itself. This says x equals 2 over 2, which is just 1. Okay? So the solution to this system of equations is 1, 2. And we can express that as an ordered pair, notably as 1, 2. Again, in an ordered pair, your x comes first, your y comes second. So the answer to this one is either x equals 1, y equals 2, or 1, 2. So that's going to be, as we can see, B. All right, number 7 says, find the equation of the line passing through the points 3, negative 1, and 4, 7. All right, this is a very common question you'll see on the ASVAB. It's not that easy writing an equation of a line, believe it or not, because there's 3 different ways you can do it. In this case, the very first thing we're going to have to figure out is the slope of this line. And in case you forgot, slope, which is given by m, is y2 minus y1 over x2 minus x1. And in case you haven't seen this in a while, you might be saying, where do I get x1, x2, y1, and y2? Well, those correspond to the values in your ordered pair. So I'm going to call this one x1, y1, which means this will be x2, y2. So let's just plug those in accordingly. Again, y2 is 7, so this is 7. y1 is negative 1, so this is minus negative 1. x2 is 4, minus x1 is 3. Okay, let's deal with this negative, negative. Negative, negative is the same as positive. Okay, so this is 7 plus 1, which is 8. And then this is 4 minus 3, which is 1. 8 over 1 is just 8. Again, anything divided by 1 is just that number. All right, so we can see our slope is 8. Now we have to figure out how to write the equation of the line using the slope and these ordered pairs. Well, that's actually pretty easy to do. If you know the point-slope equation, you can do that very quickly. The point-slope equation is this: y minus y1 equals m times x minus x1. We already know what m is. We found that to be 8. We know what y1 is. Again, we labeled that over here accordingly. And we know what x1 is. Again, we labeled that over here accordingly. So all we have to do is plug these values in and then solve for y. So let's see what that looks like. And again, in case it's helpful, let me bring this over here. We have 3, negative 1. This is our x1 and our y1. So we have y minus y1 is right here. It's negative 1 equals m. M was 8. That's down here. Times x minus x1. x1's right here. It's 3. Okay, let's take care of this double negative. We know that's going to be positive. And now let's take care of this 8. This 8 is being distributed to this x as well as to this negative 3. So this is y plus 1 equals 8 times x, which is 8x. And then 8 times 3, which is negative 24. All right, the only thing we have left to do is to get y by itself. So I'm going to subtract 1 from both sides. This crosses out, leaving you with y equals 8x minus 25, which is right here. So we've written our equation of the line. Let's see if that's there as an answer choice. It is. It's D. Okay, so that's that one. Again, you do have to be proficient at writing equations of lines for the ASVAB. And as I mentioned, this can be tricky because there's 3 ways you can do it, depending on the information that's given. I do have a video on writing equations of lines, and in that video I discuss those 3 methods. So if you struggle with this, make sure to watch that video. It should become very obvious after you watch that. All right, number 8 says completely factor. We have x squared minus 5x minus 6. All right, I'm going to copy this down. We have x squared minus 5x minus 6. Whenever you have a quadratic that has a leading coefficient of 1 here, it's going to be factored like this more than likely. X times x. And now we're looking for two factors that multiply to -6 but add to -5. Okay? So let's think about what we're going to do here. I'm going to do -6 and +1. Again, -6 times +1 is -6. -6 plus 1 is -5. So those are our two factors, and we're done with this one. Again, factoring is something you have to learn. And so if you need more practice, watch my video on that. But that said, let's go ahead and make sure we select the right answer choice. This is x plus 1, which we have here. This is x minus 6, which we have right here. Okay, another method you can use to solve this one is to take all of these answer choices and actually expand them by foiling them. But that said, that will take a very long time, so you don't want to go that route unless it's absolutely necessary. Okay, so that's that one. All right, number 9 says the diameter of a circle is 8 centimeters. What is the area of the circle? So we're dealing with a circle here, and we have to know what the definition of a diameter is. Diameter, in case you forgot, is the distance from one edge of the circle to the other edge of the circle and through the center point of the circle. So that's the diameter right there, which I just drew. And we know in this case that is 8 centimeters. When you're finding the area, you're going to make use of the formula area equals pi r squared. So you can't use this diameter. Instead, you have to figure out what the radius is. Well, the radius is the distance from the center point to the edge of the circle. And as you might expect, the radius is always half the length of the diameter. So we can represent that as diameter over 2. Again, the diameter in this case is 8. 8 over 2 is 4. So this radius is going to be 4. So let's just plug in 4 for our r here and work this out. This is area equals pi. Radius is 4, so this is 4 squared. This is area equals 4 squared is 16, so this is 16 pi. And let's go ahead and look at our answer choices here. For the ASVAB, you're always going to have to let pi be 3.14. In some cases, it will specify that pi is 22 over 7. But again, more often than not, you're going to use 3.14 for pi. So this becomes area equals 16 times 3.14. So let's work that off to the side. Again, we have 16 times 3.14. That is to say, we're multiplying a whole number by a decimal. And as we've seen in this video already, we want to get rid of this decimal temporarily such that this math becomes a little bit easier to do. So I'm going to shift this decimal and 3.14 2 times to the right. And that becomes 314 times 16, albeit with those 2 decimals to shift back into the left, which I shifted to the right over here. And again, I put this 314 above 16 because it's a bigger number, and that's how you do multiplication. You always put the bigger number up top. Okay, so let's go ahead and work this out. We have 6 times 4, which is 24, carry a 2. 1 times 6 is 6, 7, 8. 6 times 3, of course, is 18. Before we start multiplication with this second term, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. All right, let's add these together. We have 0 plus 4, which is 4. 8 plus 4, that's 8, 9, 10, 11, 12. Carry a 1. 8 plus 1, 9 plus 1 is 10. carry a 1. 3 plus 1 is 4 plus 1 is 5. Bring our 2 decimals back in. 1, 2. So we can see the area of this circle is 50, 24, and that's going to be centimeters squared. Again, squares always go with area, whereas cubes always go with volume. So this one is A, 50.24. All right, so that's that one. Number 10 says the perimeter of a rectangular pool is 56 meters. If the length of the pool is 16 meters, find its width. All right, so for these problems, I like to draw a little diagram to illustrate what's going on here. And we know we're dealing with a rectangle according to the problem. And we know the perimeter of this pool, which I'm going to call P, is equal to 56. Likewise, we know the length of the pool is 16 meters. Okay, so here's the length of this rectangle. We know that's 16. Likewise, we know that in rectangles, if this side's 16, this side's equivalent to this side, so this is also 16. And that leaves us with trying to figure out what these two widths are. And I'm going to represent those with an X since they're currently unknown. All right, so how can we figure out what X is given the perimeter of this rectangle? Well, we do know that to find the perimeter of a rectangle or any quadrilateral, you just add up all the sides. So the perimeter is equivalent to X plus 16 plus X plus 16. Okay? And likewise, we know what the perimeter is. The perimeter, according to the problem, is 56. So in place of P, I'm going to put 56. So this becomes 56 equals X plus 16 plus X plus 16. All right, so let's combine our like terms. We have X and X, so this is 56 equals 2X. 16 and 16 is going to be 32. And it should be obvious now that if we solve for X, we'll know what the width of this rectangle is. Okay, because again, X is right here. We're solving for X over here. So the very first thing I'm going to do is subtract 32 from both sides. This crosses out here, leaving you with 2X over there. And I'm going to work this out the long way. 6 minus 2 is 4. 5 minus 3 is 2. So this is 2x equals 24. Again, our goal is to get x by itself since that's the width of this rectangle. So I'm going to divide both sides by 2, which will leave me with just x. You can see x equals 24 divided by 2, which is 12. So in other words, the width of this rectangle, which is given by x, is 12. So we can see that this one is D. All right, so that's that one. All right, number 11 says, find the mean, median, mode, and range of the following. We have 116, 130, 120, 125, 140, and 125. So for this one, I'm going to start by rearranging these values from least to greatest. So that's going to be 116, and I'm going to check them off as I do them. 116, then we got 120, then we have 125 twice, 130, and then finally we have 140. All right, so that's the values I'd ranged from least to greatest. The mode is probably the easiest one to figure out. That's the number that appears the most frequently in your data set. And as we can see in all these terms, whereas all of them appear once, 125 appears twice. So for this one, I'm going to say our mode is 125. Okay? Range is pretty easy to do. You take the biggest term and you subtract it by the smallest term. And if you arrange them from least to greatest, that means you're subtracting this one by this one. So range is biggest minus smallest, which is 140 minus 116. Again, you could do this mentally if you wanted to, but again, on the ASVAB, You don't want to make those little mistakes that are going to cost you an easy question like this. So this is 140 minus 116. We'll just work it out very quickly. 0 minus 6 we can't do, so we're going to have to borrow. This is going to become 3. This is going to become 10. 10 minus 6 is 4. 3 minus 1 is 2. 1 minus nothing is nothing, so we can see that this is 24. Median is also pretty easy to figure out. That's going to be your middle term. Okay, and to find that, you start crossing off terms at each end until you get to the middle term or the middle two terms. If you have an even number of terms, you're going to have to find the average of the two middle terms to find the median. So let's go ahead and do that. We're going to cross off one here, one here, one here, and one here. And in case it's not obvious, there are 1, 2, 3, 4, 5, 6 terms in this data set, which means to find the average, you're going to have to take the average of these two middle terms. Again, there's nothing I can cross off evenly at both ends to get one of these to be in the middle. So to find the average of those two middle terms, you do 125 plus 125 divided by 2. And this should be pretty easy to do. This is going to be 250 divided by 2, which is just going to be 125. So our median in this case is going to be 125. And finally, we have to find the mean or the average, and that's the most time consuming to do. And to find the average, you take the sum of all the numbers in your data set and you divide that by how many numbers there are. Okay, so that looks like this. We're going to take the sum of all these numbers, 116 plus 120 plus 125 plus 125 plus 130 plus 140. And this isn't going to be as bad as you think, since the numbers aren't that hard to work with. And again, there are 1, 2, 3, 4, 5, 6 of these. So we're going to divide by 6. All right, so in an effort not to make any simple mistakes, I'm going to add these vertically like this. I'm going to do 116, 120, 125, 125, 130, and 140. And then we'll come back and do the division after we add these. So this is 5 plus 5, which is 10, plus 6, so this is going to be 16. So we're going to drop down a 6 and carry a 1. Let's go ahead and work on this. 3 plus 4 is 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 15, carry a 1. This is 1, 2, 3, 4, 5, 6, 7. Okay. So this becomes 756 divided by 6. Again, you can regard all fractions as long division, so I'm going to read this as 756 divided by 6. And this is actually pretty easy to do. We start by asking ourselves, how many times does 6 go into 7? Well, 6 goes into 7 one time without going over. 6 times 1 is 6. 7 minus 6 is 1. We're going to drop down this 5. Now the question is, how many times does 6 go into 15 without going over? Well, 6 times 2 will give you 12, whereas 6 times 3 will give you 18, which is too big. So this is going to be 2. Again, 6 times 2 is 12. 15 minus 12 is 3. Now we're going to drop down this 6. 6 goes into 36 6 times evenly, given that 6 times 6 is 36 with no remainder. So we can see that the average in this case is 126. All right, so for our answer, we're looking for 126. That's our mean. 125, 125, and 24. Okay. This has a decimal in it, so we know that's not it. And this has a decimal, so we know that's not it. This has a 23, not a 24. 126, 125, 125, 24. All right, so this one's it. Okay, so that's that one. All right, so for number 12, it says, if angles of measures x minus 2 and 2x plus 5 are a pair of supplementary angles, find the measures of those angles. So for this one, you have to understand that we're working with supplementary angles. And the definition of supplementary angles is two angles that add to 180 degrees. Okay? How can we use this definition to solve for x here? Well, we know this is one angle, and we know this is the other angle. So in place of angle 1, I'm going to write x minus 2. And in place of angle 2 here, I'm going to put 2x plus 5. This equals 180. Let's go ahead and combine our like terms, notably the x's. X and 2x is 3x. Negative 2 and positive 5 is positive 3 equals 180. All right, so now we're just solving for x. So let's go ahead and do that. Again, the first thing I'm going to do is move this whole value over here. 3 minus 3 is nothing, so this leaves us with 3x over here. 180 minus 3 is going to be 177. All right, we're still solving for x, so we're going to divide both sides by 3 at this point. This becomes x equals 177 divided by 3. Well, let's say you were worried about 177 being divisible by 3 evenly. Is there a way to check to see if 177 is going to be divisible by 3 without involving decimals? There is. You take the numbers in 177, so here's 177. You add those numbers together, so 1 plus 7 plus 7. 1 plus 7 is 8 plus 7 is 15. If the sum of the numbers you're trying to divide by 3 is also divisible by 3, you know that that number itself is divisible by 3. So 15 divided by 3 is 5. Since 15 is divisible by 3, I know 177 is going to be divisible by 3 as well. And let's go ahead and take a look at that. Again, this is 177 divided by 3. So we're asking ourselves, how many times does 3 go into 1? It doesn't. How many times does 3 go into 17 without going over? Well, 3 times 6 would be 18, which is too big. 3 times 5 is 15, so we're going to have to go with 5 here. 17 minus 15 is 2, and we're going to drop down this 7. 3 goes into 27, of course, 9 times. 3 times 9 is 27, so there is no remainder. X here is 59. Is that our answer? It's not, because, again, angle 1 is x minus 2, whereas angle 2 is 2x plus 5. And again, we know x is 59, so we're going to have to plug in x here to finally get our answer. And let's go ahead and do that very quickly. Again, this is angle 1 is x minus 2. We found x to be 59, so this is 59 minus 2. 59 minus 2 is 57. Okay? We're going to do the same thing for angle 2. Again, angle 2 was 2x plus 5. We know x is 59 in this case, so this is 2 times 59 plus 5. And in case you can't do that mentally, let's work it off to the side. We have 59 times 2. 9 times 2 is 18, carry a 1. 5 times 2 is 10, plus 1 is 11. So this is 118 plus 5. 118, 119, 120, 121, 122, 23. So we can see our pair of complementary angles are 57 degrees and 123 degrees respectively. Okay, so that's that one. That's a fairly common question because it tests your knowledge of algebra as well as your knowledge of the definitions of different types of angles. So pretty good question there. All right, number 13 says, what term comes next in the sequence? We have -9, 101, -999. 1001 and negative 99999. Okay, so this is a pretty challenging question. That said, and again, I took away the answer choices because it would be too obvious if I left those in. But let's see what we have going on here. Let's take a look at our nines. This nine's negative, this nine's negative, and this nine's negative, whereas these 101s are positive. Okay, so we have a pattern there. And as we can see, it goes from 9 to 1 to 9 to 1 to 9 to 1. So we know our answer is going to start with a 1 and end with a 1. Okay, so we can kind of disregard the nines at this point. We're not really looking at their pattern, but let's look at the pattern of these ones, specifically the zeros. Again, we have 1 0 here, 3 zeros here. I'm going to say for this one, we're going to need 5 zeros. So 1, 2, 3, 4, 5. And there's our answer. Again, sometimes for the ASVAB, you're going to be given a sequence that you're going to have to solve by trying to think about what pattern gets you from term to term. I do have videos on sequences and series on my YouTube channel, but I think in those videos I go a little too overboard. But if you want to watch those, you can. They should help put a simple question like this into perspective. That said, again, you really don't need advanced math to work on these. You just have to be pretty good at recognizing patterns. Okay, so that's that one. How many of these do we have left? We have 3 left. All right, so number 14 says simplify the expression. And I'm going to copy it down. We have 26a squared b to the negative 5 c to the 9th all over negative 4a to the negative 6 b and c to the 9th. Okay? So there's a lot going on in this one. And we're going to have to know our laws of exponents to effectively simplify this expression here. And specifically, we have to know this first and foremost. You can't leave things with negative exponents. So this b to the negative 5th is the same as this, 1 over b to the positive 5. Again, this negative tells you to bring that variable into the denominator. So again, these are the same. You can't leave it like this. You have to bring it down into the denominator. And likewise, if you have 1 over a to the negative 6, you can't have a negative as an exponent. This tells you to bring it to the numerator. So this is the same as a to the 6th. So the very first thing I'm going to do here is I'm going to take care of these negative exponents. We cannot have them. Okay? So let's rewrite this by fixing that. Again, this a to the squared is fine. With that said, if we look down here, we have a to the negative 6. Can't leave it. It has to come into the numerator. So this is a to the 6th. And likewise, well, we're going to move this b to the negative 5th in a second. This is c to the 9th. So we fixed everything in the numerator. Let's go ahead and fix the denominator. Again, we have negative 4. We already took care of this a. Then we have b. Let's take care of this b to the negative 5th. Again, we can't leave this negative exponent. So it's going to have to come down here as b to the positive 5. Then c to the 9 is fine. Okay? So again, right here I just cleared those negative exponents. And now I'm going to make use of 2 laws of exponents to simplify this further. Notably the product rule as well as the quotient rule. And what do those say? The product rule says this: if you have a to the m times a to the n, that's the same as a to the m plus n. Okay, we're going to make use of that. And then we're going to use the quotient rule, which says if you have a to the m over a to the n, that's going to be the same as a to the m minus n. Okay, so with those 2 rules in mind, let's see what we can do here. This 26 and negative 4, we can reduce that like a separate fraction, and let's do that off to the side. We have 26 over negative 4. if I were simplifying this fraction, I would divide 26 as well as negative 4 by 2. 26 divided by 2 is 13. Negative 4 divided by 2 is negative 2. So this 24 over this 26 over this negative 4 reduces to negative 13 over 2. Okay? All right, let's look at these a's. We have a squared times a to the 6th. Well, we're going to make use of this product rule right here to simplify that. Again, we have a squared times a to the 6th. So that's going to be the same as a, according to the product rule here, as a 2 plus 6, which is a 2 plus 6 is 8. So again, we reduced these. We just took care of the a's. This is a to the 8th. Okay. Let's go ahead and take care of the b's. Again, using the product rule, we can deal with these pretty quickly. Again, if the exponent's not expressed, it's probably a 1. So this is b to the 1 times b to the 5th. Again, according to the product rule, this would become b to the 1 plus 5, or b to the 6th. So this is b to the 6th. Okay, so we took care of the b's. Now we got to deal with this pair of c to the 9s. And we're going to make use of the quotient rule to do that. Again, we have c to the 9 over c to the 9. Well, according to the quotient rule, when you have things that have the same bases and different exponents over each other in a fraction, that prompts you to subtract our exponents. So this becomes c to the 9 minus 9. 9 minus 9 is 0. Anything raised to the 0 power is 1. So c to the 0 is 1. And if I were to place a 1 here, it would make no difference because 1 times this would be this, 1 times this would be this. So we don't have to express that. In other words, the c just disappears. So simplified, we have this negative 13a to the 8th over 2b to the 6th, which is answer choice A. All right, so number 15 says simplify the expression. We have 2 radical 3 plus 5 radical 2 times 3 radical 3 minus 4 radical 2. So I'm going to start by copying this one down. Again, we have 2 radical 3 plus 5 radical 2 times 3 radical 3 minus 4 radical 2. All right, so this is just like this in algebra, x plus 1, x plus 3. So you would FOIL this to expand it. Personally, I've never learned FOIL. All you really have to know is that you take this first term and you multiply it to this term, and then you take this second term and you multiply it then to this term and this term. If you want to think about that as foiling, that's fine, but I mean, I never learned it that way. It's just this term by these two, this term by these two. So let's go ahead and expand this. So we have 2 square root 3 times 3 square root 3, so that looks like this. 2 square root 3 times 3 square root 3. And then we have plus 2 square root 3 times negative 4 square root 2. Okay. Now that we've done those two, we can move on to this 5 radical 2 or 5 square root 2. So we have plus 5 square root 2 times 3 square root 3. And then finally we have plus 5 square root 2 times negative 4 square root 2. Okay, so at this point you're probably saying, all right, I can expand this, but where do I go from here? Well, these radicals that are the same, notably radical 3 and radical 3 there, as well as radical 2 and radical 2 there, are very, very easy to simplify. So let's work on those first, and let me show you what's going on here. First of all, let's factor out this 2 and 3. Again, let's just pull those off to the side for a second. This is the same as radical 3 times radical 3. Okay, let's think about this in terms of exponents. Again, the square root of 3 is the same as this, 3 to the 1/2 power. And this says 3 to the 1/2 power times 3 to the 1/2 power. According to the product rule, you would just add these. So this becomes 3 to the 1, which is just 3. So I know square root of 3 times the square root of 3 is just going to be 3. 2 times 3 is 6. So this becomes 6 times 3, which is 18. Okay, so that's very, very easy to simplify right there. Let's go ahead and do the same thing over here since we have basis of 2. Again, we know this square root 2 times square root 2 is going to be 2. So this is 5 times negative 4, which is negative 20, times 2. So this is negative 40. Okay, and if you want me to work that out, I will. Again, let's pull out that 5 times this negative 4 right here. Then we have square root 2, square root 2. Again, I know square root 2 times square root 2 is just going to be 2. This becomes 5 times negative 4, which is negative 20. Negative 20 times 2 is negative 40. Okay, so that's simplified right there. Now, these middle two terms are pretty easy to do as well. What you do is you multiply this 2 and this negative 4, so this becomes negative 8. And then we just place a square root here and multiply 3 and 2 together. So this becomes negative 8 square root 6. And this one's also pretty easy to do over here. This is 5 times 3, which is 15. And then we do square root 2 times square root 3. So this is 15 plus 15 square root 6. Okay? So let's clean this up a little bit. And radicals are pretty hard to deal with. That's probably the hardest thing you'll see on the ASVAB if you even see it. So this becomes 18 minus 8 square root 6 plus 15 square root 6 minus 40. All right, let's combine our like terms. Negative 40 plus 18 is negative 22. So that's taken care of. Then we have 15 radical 6 minus 8 radical 6, which is going to be plus 7 radical 6. So this one's simplified as negative 22 plus 7 radical 6. All right, finally we have x minus 3 over 4 over x over 8. We want to simplify this. Well, let's write this out down here. We have x minus 3 over 4 divided by x over 8. Again, we're dividing two fractions. This is one fraction here. This is another fraction here. And what do we know about dividing fractions? You follow the algorithm. Keep, change, flip. Okay? It's no different here. These are just what I like to call algebraic fractions. So we're going to keep this top algebraic fraction the same. So this becomes this. X minus 3 over 4. And then we're going to, again, that's our keep. Then we're going to change this sign from division to multiplication. That's our change. And then we're going to flip this second fraction. So instead of being x over 8, it's going to be 8 over x. Okay? Now we're just multiplying fractions together. So we're going to multiply straight across. So this becomes 8 times x minus 3 all over 4 times x, or just 4x. We can reduce this 8 and 4. Again, 4 goes into 4 one time, and 4 goes into 8 two times. So this reduces to 2x minus 3 all over x, which is answer choice B. Okay, so that's that one. And that is it for this practice test. Toward the end, some of the problems got pretty challenging. So regardless, I hope you found this practice test helpful. If you like the content I'm creating, please consider subscribing to my channel. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.